Hello everyone, welcome back to my channel. So today I'm going to show you how you can build your own Tetris game in Python using the Pygame library. So first, before we jump into this, I'm going to take my time and take you through this. This is a complete beginner tutorial where by the end of this tutorial you should be able to be familiar with Python and also Pygame, and you should be able to build your own games if you want to do it. So without further ado, let's get into it. So first, let's look at the demo of what you are going to build in this project. So this is the URL of what we are going to do. So you can see we have the Tetris moving down. We have the levels, we have the lines, we have the score. So the score counts as well. Everything is working perfectly. The score works, the level works as well. You can also rotate the Tetris if you want. You can also move it around or however you want. So this is what we are going to build. This is what the fully functional Tetris game build with what Pygame. So at the end of the game, at the end of this tutorial, we should be able to build this, and everyone should be able to be familiar with Pygame. So now what I'm going to do now is I'm going to move into my IDE. Now it doesn't matter which IDE you are using, be it Python, be it Test, doesn't matter. So I'm using Visual Studio Code. So here's my Visual Studio Code. I already have a folder created and a new Python file created in here already, main.py. So you can also go ahead and set up your environment in whatever code editor you are using. Then we begin. So now we are going to be using Pygame as I said earlier on. So before we do that, we have to make sure what Pygame is installed. Pygame is installed. So to do that, we use the pip to install. So in your code editor, or you can even use your Visual Studio Code, or you can even use your command prompt. You just have to go to pip install Pygame. So you can install it on your terminal or you can install it on your command prompt. So you first have to make sure we install the Pygame library. So once I click on it, now it's telling me requirement already satisfied because I've already installed this already. So if you are installing this for the first time, you should be able to go through it. You see that it will install and tell you what installation was successful. So once this is installed, now you now get into the game now. So first thing you want to do, you want to import the Pygame now, because that is what will help us with the graphics or the user input and our main game loop as well. So this is the Pygame that will help us do that. So the next thing is you also want to import random as well. So will help us to be able to switch between different kinds of Tetromino shapes that we want to use for the game. So now you also want to import the system. We'll use this to be able to quit the game. Then the next thing that we'll do is now we want to initialize the Pygame that we just import. So you can say Pygame dot init here. So we are now initializing the Pygame that we just import. Now let me put some space between this here. Okay, so now let's also create some constants. So these constants, we are going to use them for basically the grid or the cell size and the offsets. So let's go ahead and do that. So let me put some comments so it should make it easier for you to understand. So maybe let's say we put a comment like constant. I hope I spell it right. Okay, so first thing you want to do is you want to do the grid width. So grid width. Okay, so let's set a grid width like 10. They will also do a grid height. Let me just duplicate this. So this will be the grid height. I hope I spell height right. So you make this 20 as well. Then we have what the cell size. So we can do this for 30. Then we can have what grid X offset. So grid F. So X offset. Then we can do this 50. Okay. Then let me duplicate this. Then this will now become the grid Y offset. So we can keep this also at what 20. So now we also want to set some colors. So the RGB values we are going to use to set some colors. So what we do now is let me come down here. Let me just make another comment so you can separate this. So colors. Okay. So we want to set a black color. So we want to create this so that it will be easier for us to just call the color anywhere we want to use it. So you don't have to be defining this color every time we want to use it. So now we also have white as well. Then we also want to use the RGB. So let's use 255. Then finally 255. Okay. Then the next color we want to use is what? Cyan. So we also here. Now the color code supposed to be 0. Then we have what 25, 255, 255. Okay, the next color should be blue. Sorry, this should be 0. Okay, so 0 again. Okay, then we'll have what's our orange color next. Okay, so after orange, we can have like maybe yellow. Okay, so 2550. I think this is rather yellow, so this should be 165 if I'm not mistaken. Blue should be this rather. Okay, then let's come to green. So change this to 0. And then this. So let's duplicate this. Purple, because you also saw the purple when I launched the game. So we have the purple 128. So we can also have 0. The 128. Okay. So now we also want to have red, because red is also there, is important. So red color code should be 25500. I hope I'm not wrong. I'm not wrong. Okay, the final color. So final color should be gray. Final color is going to be gray. I think this should be 255, not 258. Alright, so this should be 128. 128, 128. Okay, so these are all the colors we are going to be using for the game. So what we just do is we just import, or we just create a variable and stored all these RGB version of all these colors inside the color codes, inside the variables. So it means anywhere we get into our code, we just call these colors and automatically we just have it there. So now the next thing we are going to do now is we want to create a function. So you want to set the pieces shape, for example, the color, maybe the starting position or the rotation. You see, when I launched the game, you saw that there was some rotation. I can rotate the Tetromino shapes if I want. So we can set all those rotation, the size of the Tetromino shapes and all that. So to do that, you have to define the shapes first. So to do that, I just want to do Tetromino. Okay, so Tetro means how my spelling is right. Okay, so now the I is going to be the name of one of the piece. So maybe the key, the I will be the key for the name of the piece, one of the piece. Then we are going to set the value of the rotation state. So for the eyepiece, maybe there will be two rotations. So we want to have vertical rotation and also horizontal rotation. So let me explain what I'm doing. So first we'll have to set the rotation. So we'll have a list. So this double of this is going to be a list. So let me do it this way so it'll be uniform. Yeah. So we have 4 of the periods. Or let's say 5 of the period. 1, 2, 3, 4, 5. So the shape is going to be what? Stored inside a 5x5 grid of strings. So now each of these shows one empty string or one empty space. So we'll have 5 5x5 grids. So this is what it means. So one of these shows one space in each of the grid that we are seeing. So let me open Pygame. So if you come to Pygame, you go to the browser, you search for Pygame. I hope my internet is sharp. So if you go to the official website of Pygame, the documentation, you have all this there. You can read through it at your own time. So everything is here. You have the color display, draw, event, font, image, anything at all that you want. You can also search and go through the documentation and read. So that's exactly what I'm trying to say. So it means you are going to have a 5x5 grid, and each of these determines one space in the grid. Okay. So we have our 5 grid as usual, 5 space, 1, 2, 3, 4, 5. So now we come here. So in the middle, we change this to hash. So this basically telling us that you have one vertical stack here when we get to this side of the grid. So that is what it means there. Then we'll come to let me just duplicate this. So we also want to keep another vertical stack here. Okay, so these are just bunch of what stacking for the eye shape. So now, if you look at this now, all these 5 dots that you are seeing here, all the 5 dots stands for what? 5 grids. So this is showing that this is what 5x5 grid. So if you look at what the Tetris game, you see what there is going to be about 5x5 grid, a Tetromino. So meaning what? This is what 5 empty grid spaces. This is what 4 empty grid spaces with one of the with one of the grid space being filled here. So basically that's what it means. So it means that what with the Tetromino eye shape, it means that what you have what first 4 grids is empty, then it moves to what stays in what the middle grid, middle grid, middle grid, middle grid. Then this becomes what empty grid, empty. Then what the first 3 is also what filled. The end grid is also empty. These are empty, empty. All these are what empty grid. So it means what this basically what draws more. So if you look at this is like what try to what draw a vertical piece in the center column of the 5x5 box, piece O. So I'm just going to come down and let me leave one space and indent a little. So we'll do the O as well. So once again, this is also going to be just bunch of what placement. Here we go. So this is also for the O piece as well. So this is also showing the same scenario as I gave. So this has only one rotation. So this will give what a square that looks the same no matter how you rotate it. So this is more like the square that comes. So that's that square Tetromino shape that comes. It remains the same no matter how you rotate it. It's going to be the same thing. So what I'm going to do now is what to save time, so you don't have to be try to type all this. I'm just going to what provide a link where you can copy all this Tetromino thing and paste it here to save time. So I'm going to provide a link to the description so you can just get the whole of these Tetromino shapes here. There you just paste it there. So we don't waste time with the video. Okay, so this is my full list of the Tetromino years are here. So you can see we have the T, which is what very long. So which is very long. So just to save time, you have to go through type all this. I'm just providing the link to this so you can just copy the whole thing and replace with what you have there. We also have the one that look like what the S. You also have the one that looks like the Z, as I said earlier. You also have the one that looks like what the J as well. So then there were L as well. So this is about 7 piece that would drop into what the Tetris game. So now the next thing you want to do is you want to assign or define colors for each of these Tetromino pieces. we just copy this. So Tetromino colors. Okay. So you are going to assign color to each of the Tetromino. So we have the eye. So give this one a cell color. And we have the O here. Leave this one yellow. Then we have the T also. This one will be purple. So we have the S. So we can also make this green. Then we have the Z as well. The Z. We'll make this red. Red. S and Z. Okay, the S should be green. Adam. Then the Z. So S will be green. The Z will be red. Then you have the J. The J can give it blue. So the J can give it blue. Then the L will finally give it orange. Okay. So it means that what all these colors are going to be assigned to each of the Tetromino that we've created above. So we have the IOTSZJ. The L. It's a mistake here. So this will be J and L. Alright. So now let's define another function for the Tetromino. So this function is going to, I'm going to use this function to assign the grid, also rotate, and also do all those, basically the main functionality of the game itself. So let me come down below here too. So we can say class Tetromino. So we need an init. So double underscore init double underscore again. So give it a self parameter, we'll give it a shape, and also a color. So this function will basically assign the shape, the colors, and or the breed styles to our Tetromino. So first go self.shape. This should assign to shape. Then self.color will also go for color. Also go for color. Okay, so the X will give it to the grid width.
Then we say self dot y. This will be assigned to what? 0 as well. Okay, so now let's have the function for also the rotation. So you can say get can be rotated shape. So we give it self. Then we are going to return the Tetromino is here. So anytime it rotates any of this, and just scroll up. So this will pick any of that. So let's see Tetromino sub.shape. Then we have the rotation. Okay, so we know this, what this is doing is that this will get the current rotation state of the pieces. So any of the pieces there to just get the current rotation. So maybe what either the piece is coming with the default shape, it's coming there, or maybe it's rotated along the way by the user. So this is basically what to do. It just gets that shape for us. Okay, so now let's continue this. Then first of all, before I even continue, let's say name double underscore name double underscore main double underscore. Okay. So this, that will say main. Okay, so I'm going to come down here. So we need another function. So this function will be what? Get cells. Get cells basically. So self. So cells. This will be a list. So it should be there that way. Okay. So shape, we have cell dot depth rotated. Or is it get rotated shape? Okay, so anytime the current state of the rotated shape is taken, we are basically going to get that into ourselves there. So let's just say form row so for I row in the and rate say shape. We say for J row Now go if cell is equivalent to we cannot come and say cells dot append cell but y so plus I. So then we will finally return cells. Okay, so now what basically we doing here is that now this will convert the shape pattern. So for example, maybe the 5 will convert the shape pattern like the 5 by 5 grid, as I said before, into maybe an actual grid coordinate on the root. So for example, let's say, as I was saying, let me explain again. Let me say if we have x, for instance, so if we have x is 4 and y is maybe 0. So this method will just translate it to something like this. So we'll say, we'll try something like maybe 6 and 0. So basically that's what I'm trying to do here. Okay, so now let me come here now. So now we are going to have a class for our Tetris. So you can say class Tetris. So let's say define. So this can also be an init function. So double underscore init double underscore self. Okay, so we have self dot break. So now we are going to be using the colors that we have here. So I hope you now remember we have the colors that we assigned there. So if I use any of the words in the the variable in there, you should know where they came from. So here we have our black. So for underscore in range. So in the range, we'll put our grid width there. So I also know we have it here. So this is our grid width. We'll just copy it. Okay. So grid width. Then we'll be here. Then we say 4 underscore also in. Let me copy this. So in range, grid height. Okay. Then we just come down here as well. So you can say self dot current piece. Self dot current piece. If assigned to self dot get new piece. So it means when the new piece comes, the current piece comes, this will get the okay, let's keep it this way. I think this should work. Okay, so self dot current piece is assigned to self dot that new piece. Okay, we can also make another one for self next place. And self dot get new place as well. So get underscore new place next place. No, new place, no next place. Okay, so self dot current piece assigned to self dot get new piece, then self dot next piece should be piece. So self dot next piece also assigned to self dot new piece. Self dot get new piece. So it's basically there. So self dot current piece assigned to self dot get new piece, self dot net piece, next piece also assigned to self dot get new piece. Okay. So now we'll come here and say self dot our score assigned to 0. We'll also make a line self dot lines cleared assigned to 0. Self dot level also assigned to 1. Then we'll finally have self dot 4 time. Okay, so this will assign to 0. Self dot 4 speed. So 500. So this one is basically in milliseconds. So 5, that means like 500 milliseconds. Okay. Then right under this, we also have the functions that we define here. We assign here. So let's now define them now. So get new piece will come. So we'll define get new piece function self. Okay, so basically what we did here is we just have the empty grid here. You know, our empty grid is going to be about 20 rows by 10 columns. So then what we have to spawn the first piece to prepare for the next. So if you spawn the first piece to prepare for the next, then it will also keep track for the scores, the line, and the force speed. So in the range, anytime it falls within the range, it's going to keep track for the level, the fall time, the force speed, which is for 500 milliseconds. Then, okay, so now in the get new piece, what should we do? You can say, you can now give the shape. Now random dot choice. Okay, list. So let me just scroll up here. Where are you? So Tetrominos. You are going to call the Tetrominos. So where am I? I'm here. Okay, so inside the list, you see Tetrominos.keys. So it will get any of the keys. Either it's key I, or be it key Y, or be it key Z. So depending. Okay. Then from there we'll return Tetromino. We'll say shape. So you have the Tetromino here, the function which you have here. So we return this function. Okay, so we see the shape. Then we also have the Tetromino colors that we assign here. So each shape, so it will return into the shape and the colors. So we'll just do shape and there. Okay. Then we'll also do same for, let's do a new function like is valid position. Okay, so we'll give this some parameters over the self. So self place. No place. I don't know why I keep using place instead of piece. So self piece. Var ds assigned to 0. dy assigned to 0 as well. The rotation will be none. Okay. So under this, so we need to bring this here. Okay. So we can say if rotation is none, then we can also say rotation will be piece dot rotation. Piece dot rotation. So if, let me make sure we are on the right track. So if rotation is none, then if so it's valid position self piece dx dy rotation none. If rotation is none, then you know rotation is also assigned to piece dot the same rotation here. Okay. So okay, I think it should work. So let me see. Column rotation. temp rotation should be piece dot rotation. So temp rotation will be piece dot rotation. You can also say piece rotation will also be rotation. Okay, so let's do some loop here. So for x, y, and piece dot get cells. So you can say x must be dx. This should be dy. So if x, so I will explain this once I'm done with it, so don't worry about that. So less than so I can say also greater than equal to our grade width. Let me just make sure I'm using the right variable. So let me just copy the variable itself here. So grid width. So come here all. So this should be grid height. So we can also say y greater than or equal to 0. Self dot grid. So we have our yx all in a list form. So piece the rotation here. This gives you temp rotation. That will now return the force. So return some boolean here. So let me come. Yeah. Yes, a piece dot rotation. This rotation, you have sent a temp rotation and will return true here. Okay. So now what this does is that now this function we have here will check if a Tetromino can be moved or rotated without colliding with the walls, the floors, or maybe the blocks. So that's what it's just doing here. So it will just check to make sure that any of the tetrominos that we have, any of the shapes that we have, because we don't want them to be colliding with each other. So that's not the best game experience. So this we check if the tetromino what is either being colliding or can be moved. The channel can be moved or rotated without colliding with any of the walls that we have there. Okay, so it means that if we come here, let me break it down. So that's what it means. So it means that here, for instance, what we are saying here is that if no rotation is passed here, if no rotation is passed, then we'll use the piece current rotation. Then if the new rotation is passed, then we'll test that instead. So if new rotation is passed, we'll just keep the current rotation as you have. So if the user rotates it finally, if the user doesn't rotate, fine. But if the user rotates, then we are going to use the current rotation. But if the rotation is passed by the user, maybe the user rotates the tetromino piece, that means we'll now use the new rotation by the user. So this is basically what we have here. So it means this saves the old rotation, then sets the new rotation to the test rotation. So but we'll resolve this one later. So that the piece doesn't permanently change. So if we look at this, we say what for x. So for x, y in piece dot get cells, then we have the x, then we have the y here as well. So this one will get every x, y cell of the piece. So remember we created a function here that will say, you make this here that will say we'll convert when it picks the position from the x and y, to pick the position from the x and y, then convert it to maybe a coordinate like this. Other maybe it's y, coordinate of x, y. So if get a position of 6 and a y position of 4, or position of 3, 2, we convert this to 3, 2. So after it gets the current position for the piece that we have, which is how in the form of the coordinate that I show you. So it will apply that movement to the dx and dy. So it will, if it's x is 6, it will apply that movement to dx. If y is 10, it will apply that movement to also the dy. So if dy is less than 1, then which means it will move it to the left. And if dy is 1, so this the increment. So maybe for example dy is less than 1, this will move it to the right. If dy is what maybe greater than 1, if dy is greater than 1, then it will what move it down, to move it down. Okay, so if x is less than, so that's what we have here. If x is less than 0, then the piece goes outside left wall. Then if y is greater than then it what the piece will go outside right wall or hit the floor. Okay, then the spot will be just filled by another block that we have there. Then finally here we are saying that what if the piece is invalid. So if invalid, then put back to the original rotation. Then we return false here, invalid. But if it's valid, then we return no issues. So we just restore back to the current rotation. Then we just keep true. Okay. So this is basically all I was doing here. Not anything bigger. Yeah. Okay. So now let's now make a function for the place piece. So now let's make a function now for the place piece. So we can now say, we define that function here, like definition. Let me say place we can say self, then piece. So we can say maybe for x, y in piece dot get cells. So for x, y, then in piece dot maybe get cells. We'll just use the if function here. So if y then we'll have the self dot grade and we'll have the x2 as well. So we can say piece dot color non-defined clear lines. Okay, so we define clear lines here. Then this line, we say lines I'm going to assign this to an empty string. Then for y in so let me make sure. So maybe say def place piece. So self piece. So we say well for x, y, and p get cells. Then we can say if y this, we can say this y x. This should be the piece dot color. Okay, so what we done here, what this does is now we'll say what this will take the current piece. It will take the current piece rotation. Then it will lock it into the grid once it can no longer move down. So that's it. Then the loops will go through. So that's what we have here. So the loops will go through to avoid filling the cells that are above the visible area. Yeah. So with basically the method will drop the piece permanently into the grid once it's landed. So now let me finish this. Let me see. So we say if clear lines self, we can say lines clear empty. So for y in range, the range is to be better if we give it a grid height. So let me put grid height here. So grid height, this should be okay. So now we can also say if all so if all 0 we have black 4 0 in for some is sub dot grid So you can now say lines underscore to clear. You can say dot append. You have the Y, and then can go ahead again and say for Y in lines to clear. And I say self dot breed. So self dot one. So from here, self dot breed dot insert. So let me call the black color that we have. So black for underscore in range. So let's go for breed width. So this will be the width. So let's say lines cleared. Lines cleared. Add lines to clear. Then we can say self dot lines so self dot lines cleared. So lines cleared. So now right below this, we can now make the scoring system. So let me just say something like scoring system. Okay, so before we even go ahead and make the scoring system, so for example, when we come here like this, okay, so now here we say, well, this will now check the row for us. This will check the row for Y. And then if there are no empty if there are no empty cells where black exists, then it means that what the row is full of what the mark. Okay, so this will check. Sorry, so this will check for the Y row. So if the row is empty cells, which is where the black exists, then it means that what the row is right mark for removal. Then it will delete the full row now. Then add the empty black row at the top so that the blocks above falls down. So it will add them so that the block above will fall down. So that's it. So then here, so basically this will store how many rows got cleared. Then use for scoring then the level. So that will create the scoring and leveling here in that way. So in the scoring system, you can say if lines So if lines cleared, so else if lines cleared, this one is 2, and then we can just copy this. So once we can say self the score, then we just give this 100. Hold on. So same way here. Else if lines let me just copy this. Three. Then we'll make this plus 300. Then let me just duplicate this line again. So this should be 4. Then we can just say 1,200. Okay, so we'll just come here, we'll say so we can also say self.level. Self.lines cleared. So self.lines cleared. We have this here. Then self.force speed. Okay. So in here, let's say self.level. This will be by 50.